Imagine a luxury, multi-million-pound home manufactured completely by autonomous robots inside a climate-controlled factory and fully assembled on a UK plot in under 72 hours. While traditional brick and mortar sites spend months fighting unpredictable British weather and labor shortages, a quiet revolution in advanced material science is allowing engineered timber to achieve structural tolerances tighter than a high-end Swiss watch. Today, Tier 1 architects are completely abandoning standard building methods for off-site timber prefabrication. By shifting the entire construction process into automated, aerospace-grade manufacturing facilities, the UK housing market is witnessing an unprecedented leap in thermal efficiency, structural speed, and asset longevity. To pass strict UK building regulations while delivering elite architectural forms, developers are relying on 5 specific structural breakthroughs. And later in this video, we will reveal the exact digital twin technology that guarantees a mass timber home will remain structurally perfect for over a century, leaving traditional concrete structures looking completely obsolete. Traditional timber frames rely on manual cutting, which introduces human error and loose structural tolerances. Robotic computer numerical control, or CNC, machining entirely eliminates this variability. Computer software translates a digital architectural model directly into automated cutting arms. These massive industrial robots cut, drill, and route solid glulam and engineered timber beams with sub-millimeter precision. Because the cuts are accurate down to fractions of a millimeter, the wood pieces form interlocking joints that transfer structural loads with near-perfect mechanical efficiency. This eliminates the reliance on heavy steel brackets or chemical fasteners that degrade over time. The structural integrity is built directly into the geometry of the wood itself. Across premium developments in the home counties and London outskirts, custom self-builders are deploying CNC milled oak and spruce frameworks. These components are delivered sequentially on flatbed trucks and locked together like a giant, ultra-premium puzzle. Brick and mortar builds inherently suffer from material inconsistency. Bricks vary in size, and mortar expands or cracks based on moisture levels. CNC machined timber provides absolute dimensional stability. When the wall panels arrive on a UK plot, they line up perfectly the very first time, completely eliminating costly on-site modifications. But cutting the frame with robotic precision is only half the battle. To survive the modern climate crisis, the walls themselves must become active thermal barriers. Which brings us to technology number 4. An advanced closed panel system moves the entire envelope building process off-site. Instead of erecting a bare wooden frame and layering insulation in the rain, these panels are fully completed inside a factory. A single closed panel contains the structural timber studs, high-performance vapor barriers, pre-routed conduits for electrical wiring, and dense layers of recycled wood fiber insulation, all sealed tight under massive industrial press beds. By manufacturing these walls horizontally under factory-controlled pressure, the insulation is packed completely tight, preventing any settling or subsequent air pockets. This results in an incredibly low U value, often dipping below 0.11 watts per square meter Kelvin. For the homeowner, this represents a structural shield that traps heat in the winter and rejects it in the summer with almost zero energy consumption. This tech is rapidly becoming the gold standard for high-end UK passive house projects in regions like Scotland and the Southwest, where thermal performance against driving rain and freezing winds is paramount. Standard cavity walls built on site with concrete blocks are highly prone to thermal bridging and hidden insulation gaps caused by poor workmanship. Closed-panel timber systems are systematically tested for airtightness before they ever leave the factory floor, ensuring your home functions as an engineered energy vault from day one. But this is where modern wood does something traditional masonry never could. It allows a structure to be engineered in a digital space long before a single tree is ever harvested. If you think prefabrication just means fast assembly, wait until you see the microscopic material science driving our #1 spot. Cross-laminated timber, or CLT, is essentially structural wood, engineered on steroids. It is manufactured by stacking multiple layers of kiln-dried timber boards perpendicularly at alternating right angles to one another. These layers are glued together under immense hydraulic pressure using high-performance, non-toxic adhesives. Because the wood grain alternates direction with every single layer, CLT panels achieve absolute dimensional stability and structural bidirectional strength. They do not expand or contract with moisture changes. A CLT panel possesses a strength-to-weight ratio that easily rivals structural steel and reinforced concrete, allowing it to act as load-bearing floors, roofs, and core structural walls in megastructures. Look at pioneering urban architecture across London and Manchester, where multi-story residential blocks are being built with exposed CLT interiors, creating a highly satisfying, premium biophilic aesthetic that commands a massive real estate premium. Pouring a concrete floor slab requires extensive temporary formwork, heavy steel rebar installation, and weeks of curing time, all while remaining completely vulnerable to frost and rain. CLT panels arrive ready to bear weight immediately. A crane drops a massive floor slab into place. It is secured in minutes. When factory-built timber components meet on site, immediately the joints must be sealed with absolute precision. As these modern timber engineering solves this by integrating smart vapor-variable membranes preventing and high-tech Intumescent modern homes directly onto the panel edges during factory fabrication. That is where our next technology redefines off-site molecular structure based on relative humidity, opening up to allow moisture to escape the timber, or tightening to prevent air infiltration. This technology guarantees that the structural timber core stays completely dry, entirely eliminating the risk of interstitial condensation or rot. Furthermore, if these engineered seals ever detect extreme heat, they chemically expand up to 30 times their original volume, completely choking off any air gaps and isolating potential fire or smoke hazards locally. This system is mandated in premium eco-districts across the UK, ensuring that modular timber buildings easily surpass the strict Part F and Part L requirements of UK building regulations. Traditional brick builds rely on wet plastering and generic expander foams to achieve airtightness, both of which degrade, crack, and pull away as the building naturally settles over the decades. Smart engineered membranes expand and contract dynamically with the building, keeping it perfectly airtight for generations. And now, we arrive at the absolute pinnacle of modern off-site timber construction. The single technology that bridges the gap between digital data and physical luxury. The verdict from global structural engineers is entirely undeniable. The old-fashioned view that timber construction is limited to basic cabins or weak frames is a myth completely destroyed by modern material science. By combining digital twin modeling, advanced cross-lamination, and robotic factory prefabrication, engineered wood has emerged as the most mathematically predictable, structurally stable, and thermally efficient material we can deploy. Shifting away from slow, carbon-heavy concrete toward precision off-site timber systems isn't just an environmental trend. It is arguably the highest evolution of luxury residential engineering available today. If you were designing your own premium architectural self-build right now, would you choose the hyper-precision of a robotically manufactured cross-laminated timber system? Or would you still fall back on traditional British brick and mortar? Let me know your exact reasoning down in the comments. I read and reply to every single one. If you appreciate advanced material science breakdowns and want to see how modern engineering is rewriting the rules of luxury architecture, make sure to hit that subscribe button and turn on notifications. Welcome to the future of construction. Welcome to Wood Matrix.